Hello everyone. In this lecture, we are going to learn about amplitude modulation. Amplitude modulation. It is one of the most fundamental concept of analog communication. But before moving towards definition and AM, let us have a look at both the words amplitude and modulation. Now, what is amplitude? It is written to define a signal, we need to consider two aspects: its amplitude, which is the value of the signal, and the duration for which it exists. Now, in this diagram, you can see this is the amplitude of the signal, and this is the time duration for which the signal exists. Generally, the message signal or the human speech is of baseband nature. What does baseband mean? Baseband signals are those signals whose Fourier transform is close to zero or DC frequency. We'll see this in future lectures. Now let us move forward. Modulation. Modulate simply means to change or to control. Modulation involves changing or controlling a particular aspect of something. Now, let us simply combine both the words. Amplitude plus modulation. It means varying or changing the amplitude of the signal. What we are doing in amplitude modulation is we are varying the amplitude of the signal. We'll see how we vary the amplitude, but important thing to note here is we modulate high frequency carrier wave with respect to low frequency message signal. We always modulate our carrier wave with respect to our message signal. Now, what is carrier wave? What is message signal? We are going to see. Okay, now I have taken MT, a simple message signal in sinusoid form. AM is the amplitude of the message signal. Now, if we are changing the amplitude of the carrier wave with respect to our message signal, then it is known as amplitude modulation. Omega m is the frequency of the message signal. If we are changing the frequency of the carrier wave with respect to our message signal, then it is known as frequency modulation. This omega mt plus theta is the phase of the signal. If we are changing the phase of the carrier wave with respect to our message signal, then it is known as phase modulation. Now, one question must be arising in your mind. Why we are performing modulation? Why we are changing amplitude, frequency, or phase of carrier with respect to our message? So now let us see why. Modulation is essential in communication systems because low frequency message signals like human speech are naturally unsuited for direct long distance transmission. Our message signals like human speech are of generally baseband nature, so it is not suitable for long distance transmission. To solve this problem, we perform modulation. Another reason for modulation is practical antenna size. For efficient transmission, an antenna size must be comparable to the signal wavelength, which is lambda by 4. Low frequency audio signals have extremely long wavelengths. Example, if you want to transmit a 20 kHz signal, you would need an antenna of approximately 15 km, which is practically not suitable. Modulation shifts the message to a high frequency carrier, reducing the required antenna to a practical size in meters or centimeters. One relation you must have seen, which is lambda equals to C by F. Now, if we increase the frequency, we can reduce the wavelength. So, by increasing the frequency or transmitting our message with the carrier, we reduce its wavelength. And we all know the antenna size is directly proportional to the wavelength of the signal. So, if we reduce the wavelength, the antenna size also reduces. Now, another reason for modulation are as follows: preventing signal mixing. Without modulation, all baseband signals, like multiple radio stations, would broadcast in the same low frequency range and interfere with each other, becoming a jumbled mess of noise. Modulation allows each source to be assigned a unique high frequency channel, which we call frequency division multiplexing, keeping them separate. So now, if we want to transmit various messages through the same channel, what we do is frequency division multiplexing. By allocating all the messages different frequencies, we transmit through the same channel. Another reason for modulation is increased communication range. Low frequency signals have low energy and attenuate quickly in the atmosphere. High frequency carrier waves can travel much farther through space or cables without losing significant strength. We have seen the baseband signals generally have low energy and they attenuate quickly in the atmosphere due to the various reasons. But high frequency carrier can travel much farther through space or cables without losing their significant strength. Another reason is improved quality and noise immunity. Higher frequency signals are generally less susceptible to external environment noise. So we perform certain modulation techniques like FM. These are more susceptible to the noise. So I hope you understand the reasons why we are performing the modulation. Now, let us have a look at amplitude modulation. The conventional definition for AM is as follows. Amplitude modulation is a technique used in communication where the amplitude, intensity of a high frequency carrier wave is varied in direct proportion to the instantaneous value of a low frequency message signal such as audio or data. Now, important thing to notice is I have highlighted amplitude, high frequency carrier wave, and low frequency message signal. What we do in amplitude modulation is we have a low frequency message signal, we use a high frequency carrier wave, and by combining both of this, we transmit our message signal with the help of the carrier wave so that there can be less attenuation and effectively we can transmit our message signal. In simple terms, we can say amplitude of the carrier is varied according to the message signal. I have told earlier also, our audio signal is generally baseband signal. Baseband signal means Fourier transform must be close to zero or DC frequency. Carrier is of high frequency. We generally use cosine wave of high frequency as a carrier wave. You can also think of this as if you want to move from Jaipur to Delhi. Then, if you start walking, there is possibility that you might reach midway or get exhausted. But if you take a bus for the same route, you can reach your destination without losing your much energy. This is the same case with the amplitude modulation. We transmit our message with the help of high frequency carrier wave, in the above case the bus, so that we can efficiently transmit our message. Now, MT equals to AM cos 2 pi FMT. This is our message signal of baseband nature. AM is the amplitude, FM is the frequency of our message signal. And we take a carrier wave of cosine nature of high frequency. Important thing to notice, our carrier wave is of high frequency. It means FC is much greater than FM. Now, to generate a AM signal, what we do is we simply multiply both this, multiply message signal and carrier signal, MT into CT. This expression, what we get is our AM signal, or to be more precise, it is DSBSC signal, double sideband suppressed carrier. Okay, so this is the basic block diagram for our amplitude modulation. Information signal is our MT, carrier signal is our CT. This is the amplitude modulator, or we can simply say a multiplier, which multiplies MT and CT. And this expression ST is the modulated signal. So this is the basic idea how does amplitude modulation works. Now, there is another diagram. This is the baseband signal, or we can say our message signal of low frequency. This is our carrier wave or cosine wave of high frequency. What we do is multiply both, and the resultant, our amplitude modulation signal, looks like this. This is our carrier wave, this is our message signal. This is look like envelope in which our message signal is getting transmitted. Now, there are various types of AM like DSBSC, double sideband suppressed carrier, double sideband full carrier, single sideband, vestigial sideband. We'll look each of these in detail in the upcoming lectures and look at amplitude modulators, demodulators, how we perform all of these. Why it is called DSBSC, why it is called DSBFC, what is SSB and what is SSB. So stay connected. Thank you.